Newton's first law of motion, or the law of inertia, has a phrase associated with it. And it starts, an object in motion tends to stay in motion, or an object at rest tends to stay at rest unless acted upon by an outside unbalanced force. Now, a key part of that is the unbalanced forces. An object at rest or an object at motion can maintain that type of motion if it has balanced forces acting upon it. Only unbalanced forces change the motion of objects. Now again, this is also known as the law of inertia. A key definition here is, what is inertia? Now, inertia is defined as a resistance to changes in motion. What that means is if you have an object that's at rest and has balanced forces or no forces acting on it, its inertia, which is a property of its mass, will maintain that motion of that object. The only thing that will change that is unbalanced outside forces. The same is true of an object at rest. If it's got balanced or no forces acting upon it, it will maintain that motion or that rest until an outside unbalanced force acts upon it. If we look a little deeper at this, inertia is a property of mass, meaning that all objects that have mass have inertia as well. And it is a direct relationship between these two things, meaning the greater mass an object has, the greater inertia or resistance to change in its motion it will also have. A couple examples of this. If you have two cars, one that's a small mass and one that's a large mass, and they're both stationary, and then you try and push them with an unbalanced force, the larger car is going to be more difficult to change its motion than the smaller car. The same is true if you have those two vehicles in motion as well, the large car and the small car. The large car has a greater mass and therefore a greater inertia, so it's going to be more resistant to that change in its motion. Let's look at a couple examples of Newton's first law of motion, or the law of inertia. Let's say you're riding your bicycle at a constant velocity or in motion, and you most likely have balanced forces acting upon you, so your motion is consistent. Now, for whatever reason, let's say that your bicycle comes to an immediate and abrupt stop. It's been acted upon by some unbalanced force which has changed the motion of your bicycle. However, you, riding on that bicycle, are not experiencing very many outside unbalanced forces. So, according to Newton's first law of motion, or the law of inertia, you, on that bicycle, are an object in motion, and you're going to maintain that motion until an outside unbalanced force acts upon you. Now, the unbalanced force has acted upon your bicycle, but not upon you, and that is the reason why you'll fly over your handlebars and maintain your motion. Vehicles are another great place to look for examples of Newton's law of motion, or the law of inertia, because we all have experiences of riding in cars, and many of these examples will seem true to us. Let's say you're driving down the road and you have a purse or other items sitting on the seat next to you. Now, you're moving at a constant velocity, and so you have balanced forces acting on the car and on the object sitting on the seat. Now, let's say you have to immediately stop the car by slamming on the brakes. Now, an unbalanced outside force is now acting on the car, causing it to change its motion and to slow down. However, there are no forces or very little forces acting on that purse or other item. In that case, that object will continue its motion and fly forward off of the seat and generally land on the floor. This object's motion serves as an example of Newton's first law of motion, or the law of inertia, because it was an object in motion and it maintained that motion because it was not acted upon by an outside unbalanced force. The final example we're going to look at is a rear ending of a vehicle. Now, this often causes head and neck injuries to the individuals in the car that's rear-ended. Now, let's say you are struck from behind by a vehicle. Now, that vehicle applies an unbalanced force to your vehicle and to your body through the car seat. But generally in this situation, there are very few outside forces acting on the head of the person in the car. Now, before these forces hit the vehicle, the head was in a state of rest. And since there are few outside unbalanced forces, the head tries to maintain that state of rest. What this causes is the car and the body move forward while the head stays at rest, making the neck move backwards, and then there's a whiplash motion that moves it forward later on. Now, this causes a lot of neck and head injuries, and so in many vehicles, in fact in most vehicles, there have been installed headrests. Now, these headrests helps to apply an outside force to your head to make sure that it also moves along with your body, minimizing some of those injuries.